This past 4 months, I tried to make an elevator that will take my Mitersaw down from the roof automatically, just with a push of a button. But let me tell you, just trying to get this elevator to go up and down from the roof has been a real challenge. But for this video, I have made a lot of progress. In our last episode, we finished off by getting some circuit board problems. I thought the problem was that the transistors I used couldn't handle the current. So I switched them to some other ones that could handle more current and tried again. Here we go. Nothing happened. Alright, I found the problem. I disconnected the motor last time I was troubleshooting just to make sure I didn't burn up the engine. So now it's connected up and let's give it a go for a third attempt. And more troubleshooting. Alright, third attempt. Now everything should work. I had to rebuild the whole circuit board, but now I have faith it should work. Okay, something should happen the moment I put this in, or plug it in. Oh my god. Should this be the other way around? Okay, what about now? Now I get nothing. I think I've gotten something wrong with how I should power the motor. Yes, you have. You see, the problem here with my circuit board isn't that it doesn't work. It works perfectly for a 3-phase motor, and I'm using a 1-phase motor, so I had to rebuild the circuit board for a 1-phase motor to make it go both directions as I wanted. I think this is 4th or 5th attempt or something, but now it should work. Oh, come on. Ah, the gearbox blew. Oh. The gearbox wasn't the only problem I had, because after trying to make it go in the other direction, nothing happened. So not only did I have to make new gears, but I also had to rewire the circuit board again. But to not make any more mistakes, I did a quick test with the circuit board on the working bench, just to make sure it's not going to be any more faults. When it comes to the gears, this time I decided to make the gears out of polycarbonate, which is said to be much stronger than PLA, which is the material I used for the old gears. So after waiting for 20 hours for them to get finished, I could finally install them in a gearbox and give it a go. Now it should work. Okay. Nope, nothing happens. One of the terminals for the 230 volts was kind of a little bit up. That could be it, so maybe now. Okay, so we're not getting power to the output terminal. Jeez, here we go. Okay, so the rope is kind of, oh, you don't have the angle, but the rope is slipping on the gear, so I gotta do double turns to make it more tight. But let's see how it does downwards. And now it won't go that way either. No, it's just slipping. Okay, now the gearbox should have twice as much grip. And the gears broke again. So 2 gears down, but we're still not giving up. Even though, just to get a quick test, it's a lot of work. Now, I've changed the gear on the gearbox and I've taken cables down here so I could steer downstairs, which is much better, I guess. So everything is wired up and all I have to do is connect up the battery. Now, it should stop. Yes! And let's go up. Come on. That's weird. Yeah, okay, I see what happened. I don't know if you could see it from this angle. The bolts or the nuts on this gearbox kind of tightened themselves, or they did tighten themselves, which kind of crushed the gearbox and locked the gears. So I'm gonna loosen it up, and then we should get some action. And now it should move. Yeah, let's go. Right, let's continue. The gearbox keeps on locking itself up. I thought I fixed it, but maybe I didn't. Maybe it was just all an illusion. Each time we test something, we just uncover a new problem, a new problem, a new problem. But eventually, we solve the problems and it should work. So it's just part of the process. Just gotta be patient. Oh, okay, I see the problem. The rope has kind of pushed itself between the gears and the wooden plate. So yeah, it definitely shouldn't be like that. So I gotta fix that. Yeah. It looked so promising to begin with. I really thought we had it there. Or I really think I have it every time, but yeah. Nope. If I... It's good speed as well. Yeah! And let's go up. Oh, wow. Okay, it locked itself up. So we definitely got some potential here, but we still have a few small problems to figure out to make it reliable enough. Because now it only works every now and then, every once. It only works sometimes. When I get this up and down thing to work, I'm gonna build some arms that gonna fold out automatically when the elevator comes down. So I got something to place the wood on when I'm cutting stuff, if you get what I'm saying. But yeah, it definitely got some potential. So to fix this reliability issue, I figured I could try making the gears out of wood instead of plastic. So the first thing I did was disassembling the entire gearbox, and once I had it apart, I started off the old pulley because I didn't really want to wait another 10 hours to get the new print. After that, I drew up all the gears and got everything ready for the laser cutter. And even though I had been patient enough to sit through multiple multi-hour 3D prints, I was still shocked by how long the laser cutting actually took. It's gonna take an hour to cut all the gears. But eventually the gears were done. So I assembled everything back together using some threaded rod to transfer the power between the gears. And once the gearbox was finally back together, I headed back upstairs to install it for what I hoped would be a very optimistic test. Jeez. Well, it wasn't. The smallest wooden gear in the gearbox broke. But instead of learning from that mistake, I made a new wooden gear and tried again. Alright, problem is taken care of, and let's get back to the usual. We're gonna test this, and something's gonna break again. It's the same problem. You know what? I'm really considering steel at this point, but the problem is I don't have the tools to make any steel gears. And yeah, the problem is the gear. I do got one more idea. Is acrylic stronger than wood? In that case, I could try to make an acrylic gear, because it's only that gear that's the problem. It's the gear that's the smallest and also carries the most load. So if something should break, it's that gear. Yeah, let's try with an acrylic gear. Look at this. None of the teeth are left on this gear. Like, yeah, I'm gonna fix this again. Okay, acrylic gear test. Let's see. The acrylic gear is, yeah, it's completely shredded. Alright, this time we're gonna try with a 3D printed gear with 100% infill, which we did have more problems with before we started with the wooden gears. I didn't change all the gears, only the gear that's furthest out and have the most load. Well, it didn't give in, and it almost went all the way up. It didn't quite fit the scope. Oh, it did actually, kinda. But hopefully we didn't break the gearbox from that. It should stop when it goes all the way up. But for some reason the elevator is tilted and the limit switch is on this side. Okay, first I want to see if it comes down. Oh, definitely sounds like a broken gear. But the question is, which one? Okay, we're getting progress. This time this gear is a problem. The teeth on that gear has broken. Apparently the plastic is stronger than wooden gears. So I gotta switch at least this one to plastic. The other ones, I think they could handle it because they have less load and more speed, so they should be fine, but this one I gotta change. Alright, this time I changed the wooden gears to plastic gears again, but this time the plastic gear have more infill, so it should be stronger, and it's also slightly wider, so get more surface area on the gear teeth. So, here we go. Either something's gonna break or it's gonna work, so here we go. That's a really good sign. That's a really good sign. Okay, and down. Oh, the gearbox is making a really bad noise. Oh, something broke. Oh, we're so close. I think all the wooden gears are a bad idea because it seems like the wooden gear broke again. It was so promising. It went all the way up this time, so we got evidence that it goes all the way up and stops, and evidence for it going all the way down and stop. Now we just have to make it do both. We are breaking, so... Alright, we know that. I'm gonna change that, fix that, and we go again. The wooden gear broke because the rope kind of tangled themselves again. So the screw solution I made earlier definitely didn't work. So if I had replaced that gear with a plastic gear, it would definitely break again. There we go. Gear has been replaced, and I also added an additional screw to the gearbox to hopefully prevent the overlapping of the ropes. So... yeah, it definitely shouldn't do that. Go down and go up by itself. Okay, what is it now? It's definitely overlapping again, but this time the gears didn't break. So maybe we have solved that problem. Maybe a new pulley design would do the trick, like building walls between the ropes so they can't overlap, but... I really thought we had it there. So after a lot of problems with the gearbox, I decided to just take everything we learned and build a completely new gearbox, which is going to solve all of the problems. So this gearbox, first off, is going to have much stronger gears. Like this is one of the gears from the new gearbox, and this is one from the old one. And as you could see, this one is much thicker, and it's also printed with 100% infill. So it should be much stronger. But the only downside with this gearbox is that it takes like days to print. But don't worry, I've already printed most of them, so we only need this gear to start building the new gearbox. And the second feature of this gearbox is that it can't overlap the ropes like it did with the old gearbox, because we only run the rope through the gearbox once, and that way it shouldn't be able to overlap. Like, I don't see how. The only thing I'm worried about is that we get too little grip on the gearbox, so to compensate for that, I made all those 3 gears rotate to hopefully get a little bit more grip, but yeah, we'll see about that. So, I'm gonna finish up this gearbox, test it once, mount it on the roof, and hopefully the elevator should be working exactly as I have imagined. There you have it, a completely rebuilt gearbox that hopefully doesn't have any flaws. I don't know, because I haven't tested it yet. But there's one thing I didn't think of when I made a gearbox, and that is, if you look closely on how the rope is shaped, it kind of looks like a P. I installed the new gearbox in its usual place, but the screw holes for where the gearbox have been mounted before are starting to lose their threads, as I've taken the gearbox down so many times. But yeah, after that I connected everything back together between the elevator and the counterweight, and gave it a go. Aww. What about now? After some more testing without finding the problem, I went back to the old gearbox to figure out why that one worked. That's when I realized that I had made yet another mistake. As I was building the new gearbox, I calculated the gear ratios wrong. So I thought I made a stronger gearbox, but in reality I had made a weaker gearbox, which does explain why the motor can't lift the elevator. So instead of rebuilding the whole gearbox again, I found a stronger motor with the same RPM, then began building a new gear to mount on the axle, installed that, then installed the motor, tested everything to make sure that I won't have any more problems, all that to make yet another attempt. So if you watch closely on my previous clip, you will notice that the pulleys are slipping on the rope again. I did pick up that problem quite quickly, but before I did anything about that, I wanted to see if the limit switcher would work on the new motor. That's weird. The limit switches doesn't work. Yeah, more problem solving. Somehow the limit switches must have been moved, or they simply doesn't work. But the motor is strong enough. Yeah. Oh. For the slipping pulley problem, I had to find a way to increase the friction in them, since the old pulleys were completely smooth. There is absolutely no friction in them. So with the limited resources I have to work with, I found a bicycle wheel, where I took the hose and cut small strips of rubber that I wrapped around the pulleys. My only concern was that the rubber wouldn't stick well to the pulley and just peel off, but still I had to test. Well, it went all the way up, it didn't stop. Ah, yeah. So the problem is the limit switch that's supposed to stop it when it goes up, stops it when it goes down. Basically, I reversed the whole thing, so I'm gonna switch over two cables and then we're good. Flip it. I gotta be careful here because it's basically exposed live wires around here, so... Ooh. Oh. No. Didn't work this time either. It's probably... Yeah, that was what I was afraid of. Did something break? Yeah, the acrylic plate that's between the cogwheels and the gears. It shattered. Shattered? Oh, English. After some more thinking, I made new pulleys with a PLA inner core, basically a hard inner core, and TPU on the outside, which is more flexible than PLAs, so I figured to myself that would make more grip. So after all my attempts to make it just go up and down, this was the attempt that looked the most promising to me. Whoa! So, yeah, this is gonna work. Power, check. Loose connection. Yep. I've been doing this so much now, so I already know where the faults are. Okay. That's a good sign. Other way. Almost. I'm guessing the problem is the rope is slipping on the pulleys again, but we're close. I guess I could push it up. Yeah. We're getting really close. No, well... I'm gonna try with the saw on actually, because with more weight, with more weight, we get more tension on the rope, and maybe it's gonna work, or maybe it's gonna make it a lot worse. And this is probably the moment the elevator comes rushing down and everything breaks, but yeah. Up we go. Oh, that's a bad sound. Urgh!